Hello. If you have ever played PC games on Steam before, it's possible you have heard about the game Path of Exile. This game has some awesome software made by developers. I'm talking about Awaken PoE Trade and others like it. Now, what I love about this software is that you can hit a hotkey and instantly get information about any item you hover over. You can see what this looks like here, where this person hovered over an item called Impale Support and an overlay popped up providing information about this item. I decided that I want to make something like it, a game overlay that would pop up when I hit a hotkey. Now, I decided on the game or kingdom because one, it has items in the game, which is a really easy criteria to fill, but more importantly, two, is that it has a database website with literally all the games inside the game, or all the items inside the game. So you can literally find anything and find information about it. Now, starting off, I initially didn't really know what to do. I kind of just decided that I would take a look at Awaken PoE Trade's infrastructure and try to copy what they used. And I noticed that they used Electron to handle keyboard shortcuts, bringing up the UI and overlays. And I thought, wow, this is perfect. It's exactly what I need. But there was a small problem. It's that I didn't really know any JavaScript other than const and let for making variables and console.log to output things to the console. But, it's just a really small matter. It's not going to stop us, right? So before we get into the code, let's actually take a look at the finished product I made. Unfortunately, it's not perfect as reading actual game data like Awaken PoE Trade does would be against Aura Kingdom's terms of service. So I had to make a interesting workaround. I'll go into more in depth about it later. Let's first take a look at the overlay. So I am inside the game now, and I have launched the overlay app that I made. So now we can at any time hit Control D and it should open up the database page. So as you can see, Control D and it's up, and hitting Control D will restore the state anytime you hit it. So let's say we wanted to make an envoy path for Sorcerer, and we thought of this genius plan of going up here, going here, maybe down here, and we wanted to play the game now. And then we're playing the game, and then whenever we hit a level, we might get an envoy point. So this is my current envoy point path, and say we get a level and then we want to just click it, but we don't remember what our current plan looks like. So we just hit Control D again and we see, oh, I have to go this way. And that's a pretty nice feature of the app, that it restores state on this. And now moving forward, let's go into the bigger part, the juicier part, and that's locating items, or searching up the hovered over item. So hover over quick ostrich, and if we hit Control F, we see that it searches up quick ostrich, and we can click it, and then just get information about it. So for the Control F hotkey, it does not restore state, and that's because whenever we're hitting Control F, we should be looking for a new item most of the time, right? So let's say we want to look at medium experience crystal. So click it, look at medium experience crystal, and we get information about it. Unfortunately, this doesn't work all the time because it's using image recognition to actually read the words on the screen. So for some of these, it might not work completely well. So let's try a bunch. 1,000 fragment scrolls. See, it didn't come up with 1,000. It came up with fragment scrolls though. But you can obviously just click fragment scrolls. Magic candy. Let's take a look. Comes up. Bouquet of dreams. So it's working quite well. It recognizes all these, but for some inputs, it might have some trouble. So this one, 70 support cube, TO. I think this TO is throwing it off. No, still nothing. Maybe if we try it again. No, it's missing out too many keywords. I think it would have to have envoy in there. But regardless, for some of these, it doesn't work as well. So these boxes here, it doesn't really work that well for. Let's take a look at this. That works pretty well. Green one. This one actually recognizes the secret stone part of this item twice. So it's thinking that it's saying flawless secret stone, secret stone. So it's coming up with this input. We can fix this pretty easily by just checking after we get the object recognition string. We can just check if there's secret stone twice, but we would have to hard code that in, which we can, which is pretty easy. So let's take a look at this one. Works pretty well. So yeah, it works pretty well on a lot of inputs. It's not completely perfect, but we're not reading game memory data, and this is the best workaround we have. So I'd say it works pretty well for what it accomplishes. So I guess now let's go into the code. And let me pull the code up. Okay, I am back, and this is the code part. So this is the Electron file. So let's start from the top and work our way down to the bottom. Firstly, we have our imports. So first one, auto updater from the Electron updater module. It just, whenever this app is launched, it'll check if there's any updates, and then it will just automatically update it, giving the GitHub releases page. App, browser window, and global shortcut. App lets us refer to the application as a whole. So this Electron file, it'll let us do things like, oh, app.on, when it's ready, check if there's updates. So like, it'll help us check for the status of the current app. Browser window lets us open up overlays. So it's what actually lets us load the database page. Global shortcut, this lets us hit Control D and Control F and create those commands. Tray, supposed to be menu. I think I made a typo earlier. So that's supposed to be menu. Tray, menu, and native image. Tray lets us put our application onto the tray. Actually, let me launch it so you can see it. So there's an icon, but it comes up on the tray. Menu lets us make a menu for the tray icon. So this lets us just exit it from the tray. Native image, it creates an icon for the app. So if I type in, oh, it's right there. So Or Kingdom Developer, it's this smiley face icon with orange hair that I made, and it's right here. And I just made this in Paint. What's next? Spawn. So spawn allows us to make a child process, and we can actually run a Python script or something else using spawn, and I will be doing that later for the Control F portion. So we're gonna be running capture.py. Next we have path, and this just lets us get the relative and absolute path, I believe, of the files. So first up, we have check if there's any updates, and then update it. That's all that does. And now we create some variables. So we have window, window2, and tray. So starting off, this is part of the Control D part, where we just open up the database page. So basically, if it's already made, then they just return. But otherwise, make a new window and load the base URL. So it'll just load this, and it retains its state because let's say we go here, barred, whatever, or we're at some item, this page, and it retains its state because of this line right here. So if it already exists, then just return. And then it will just continue on from where it ran this function. So after it's ready, then just show the window. Let's move on. So this is for the control F part, where it'll help us actually find the item that it hovers over. So this is just to log for debugging purposes, attempting to load this item. So if the window 2, so I forgot to mention, window 1 refers to the control D window. So this is just the window that retains its state, and then window 2 is the one that does the searching for the items that we showed earlier. So if window 2 exists, then try to search for this item and then show window 2 and then return. And this actually creates the window. And at the end, we call load this URL and show it when it's ready. And then I made this function. I should have mentioned this earlier. This is what the show window on ready does. It's basically just calls, hey, did the window finish loading? Or did the contents of the window finish loading? And then we just log, hey, it finished loading, and then we show the window. That's all that does. Now, for the fun part, the control D and control F. The control D is really simple. We just run, hey, make this page. If it already exists, then let us know. So if it's not visible, then currently show it. Otherwise, we're hitting Control D again, so go hide the page. And you might be wondering, why am I doing minimize, hiding, and then minimizing? Well, it just looks better, in my opinion. If you minimize it and then you hide it and then you minimize it, it just feels better, less clunky. And then this part is actually if the Control F finder, the item finder, is currently on the screen and we hit Control D, then we just want to minimize the Control F. And let's move on. So the Control F part. So if it's currently visible, then hide it, obviously. Else, if the Control D part is visible, then hide that. Otherwise, we want to show the Control F part. So let's get into this. So we have this variable capture path, and it's saying, hey, it's asking, is that a package? What package means is basically that did you create an installer for it? So basically, after I finish doing all my coding, I want to package it up and make it so other people can install it. So this is how you actually get this application. So it's an installed application, and if we go into here, you can see, hey, it was made by me. So it checks, hey, am I running this from just like a terminal window? Like, am I just doing npm run start, and am I just running it from here and then getting the window from here? Or did I actually run it from the application? So that's what that checks for. And the whitelist path does the same thing. So why do we need this? Well, the actual relative location of the Python file is different depending on whether it's packaged or if it's running from right here. So I just did this just to check how it's being run. And so first off, we have capture pi. So it finds the path of capture pi and it says, hey, we want to spawn a new Python process, and we're going to run this file called capture pi. And we're also going to pass whitelist pkl, which we'll go into later. But first, let's go into capture pi. So we hit Control F, and let's just say it's not currently showing. We're going to spawn this Python process called capture pi. So let's go into capture pi now. And then we have a bunch of imports. We'll just go into this as like we go through the code. So starting off, we create a camera using dxcam, and this allows us to basically take a screenshot of the current screen. I don't know why it started for so long, but I don't know if you can see this, but let's say I take a screenshot and do this. Control C. I'll just put it into paint so we can see it. So DXCam allows us to basically take a screenshot like this programmatically. And if we keep going, let's actually skip over the rest of this for now. We'll come back to it. And the first thing we do is we run a capture item and we store it. So capture item. What this does is it gets the current mouse position. So when you saw earlier that we are hovering over an item, so we get its current mouse position. So if I took a screenshot from here, this would be the current mouse position, this top left part. So I got the current mouse position, or whoops, let's go back to the code. Current mouse position, and I added some, I took its original values and then I added a bit to the X, a bit to the Y. And then obviously we need to go over a lot. So this would be like going over 325, and then this would be going down 105. So that's basically what I did with the item. Now you might be wondering why I went over a little bit first. Well, actually, let's go back into the game so I can show you. So I'm back in the game now, and if you hover over an item, you'll see that my current mouse position and the item box, there's a gap. So let me take a screenshot so we can see it from my current mouse position. So let's open up Paint, paste this over, let's delete all this, paste it over. So if we take a look here, we can actually see that there's actually this, if this was the current mouse position, we actually go across a little bit. So this would be my X, and then we actually go down a bit too. Now this amount is actually uniform, and it's basically 20 pixels to the right and 20 pixels down. So this is actually why we set our starting point here. And then afterwards we added 325 pixels to the X. So we're actually going to go across 325 pixels here, and we actually don't go all the way down. You would assume that we go all the way down here, but the only thing we really need is this item name. So what we're going to do is we're going to only go down to here, and then so we can capture this box. So we go down across 325, and we're going to come down 105 pixels just to get this box so we can get this item name. And over here, we're just basically checking the balance because it will throw an error if the pixel tries to access outside of your window bounds. So my window screen is 1920 by 1080. So if I try to access over, say if I try to access pixel 2000 in the X, it will throw an error. So we just basically say, hey, if I'm going over the boundary, then just set it at the boundary. Even though it won't work, just set it at the boundary. And so we make this area a tuple with the coordinates of our container. So this would be from here, this container. So x1, or new color. This would be x1, y1 over here. Or yeah. And then this would be x2, y2 over here. Right? I believe so, right? Yeah, okay, x2, y2, yeah, okay. And then we just grab the area and as a frame, and using the DXCam that we created earlier, we're gonna capture it and we're gonna return it. And then next, we're gonna parse the item. So we're gonna pass that frame. So as you can see, it's actually a NumPy array. So we're gonna pass that frame into this function called parse item. So what this is going to do is it's going to use the computer vision library. It's called OpenCV Python, or Python OpenCV, and it's going to first turn it grayscale. And we need a grayscale so we can actually run this program or module called Python tesseract, and this is basically how it determines the words on the screen. So Python tesseract we'll try to determine all these characters. And sometimes it makes some weird characters, so I just whitelisted these characters. So we say we're going to pass our grayscale image, and using these, only allowing these characters, can you try to determine what's on the screen? So I'm going to run the tesseract image to string. So given the image, turn it into a string. And it's going to return some text in the form of a string. So, and if it doesn't, then it's going to throw an error. But after we get this text as a string, we're going to throw it into string parser, because the string is not going to be perfect, and there's also some stuff that we want to modify. So going into string parser now. So this is actually for the search part. We'll go into this after we go through the string processing. So let's start from here. So first we're gonna replace the new line, because it comes with a new line, and we're just gonna make it a white space, and then we're gonna get rid of all the white space in the string. Okay, simple enough, right? Now this next part, for every word in the string, we want to turn it into an element of a list. So say if the word was hello, I am glitch gobbler, it would basically turn this into this list, and each member would be like, hello, I am, and you get the point. And that would be glitch gobbler. So it would turn into this list. And why would we need it into this list? So I have this dictionary called whitelist. So go to assets, whitelist, and it basically has all of the words that were ever present in the database website. So you might be asking, well, how did you get all these lists of words? Well, if you come over to here to items, all items, you can see that there's a lot of items, and you might be wondering, oh, so you're just going to input them one by one? And the answer is absolutely not. There's 765 pages, and there's just way too many items. So what I did is I actually just asked ChatGPT to make me a web scraper. So there's this, not that one, this one. Basically ask ChatGPT, hey, can you make me a web scraper, and can you scrape these item pages? So this is what the item page looks like, but if you actually start from page 2, you can see that items, items, page 2, and this goes all the way up to 765, right? So I basically asked ChatGPT to basically scrape any page. So make a for loop, go through every page, and scrape it. But how are we gonna get the actual items? Well, it turns out that if you actually view the page source and let's look for an item. So let's go back to all items. Let's say oak staff. We're gonna look for oak staff. First, we need to actually check. Whoops, that's right. We need to close these. So let's go back to I think it was the first page. So we're going to look for oak staff. And as you can see, we've found this item, and there's a class. And all these items share the same class. And it's flex grow 1, which I'm assuming they're using the flexbox layout, assign self center, ms2 text start. And so they're using this class for all the items, this very specific class. So we're going to take advantage of this, and we're going to scrape just this class. We're going to say, hey, if you find something with this class, then add it to our dictionary. So let's go back to the code. So it's going to create a set of all words just in case there's some like duplicates. So like words like staff, sword might come up a lot because there's a lot of different staves, and swords. So we create a set just so because we only want one of each word. and we just want to get a list of all the words, right? So this is the final output. We get basically a set containing almost like 9,000 words, and there's some foreign words as well here at the end. And so basically, this script just creates that whitelist.text with all the words. Now going back, we were here. So given our So given this, what we had, so our split words, and we just want to check first. We want to make all of this lowercase, so this would turn into hello, I am, and then it would compare it against our whitelist. So if it's in this whitelist, then allow it, because sometimes we might get words from the image recognition test or Python tesseract image recognition that might not actually align with some of the items. So it's a really easy way just to check if it actually is an item, just by doing some string parsing. So we do that, say it removes am because it's not in our whitelist, so hello I. And then afterwards, it's just gonna make it a string again. So this would just be just turn to hello I. And then we would do another check. So for each phrase and unwanted phrases, so these unwanted phrases, we just want to remove them. So why would we want this? Well, because sometimes we just look here. So Gaia Fighter treasure box, that's the name of the item, correct? But if you look under it, it says R click to open. So we don't want that when we're looking at just for the item name. So that's why we have R click to open. We just want to get rid of it, right? So remove it, replace it with just nothing. And we could actually add the secret stone part. So what we had earlier was the immaculate secret stone. That's why we're getting immaculate secret stone. So we could actually replace secret stone with actually we wouldn't put it there. We'd have to hard code it in because it's a double. So we could go after this. We could do s4.resub. re.sub, and then it would be secret stone, and we would just want to replace it with one secret stone. Whoops, I did not mean to do that. So it'd be just secret stone. It would just be whatever, the rest, right? And then after that, we want to remove all the white space again, just in case we made more. And then we want to append these pluses to it. So you might be wondering, why would we want to append these pluses to it? So let's say for the sake of argument that, what would our item be? Let's say our item was magic candy. Okay, so we have magic candy at the end of all this. Just believe that we have magic candy at the end of all this. So we're gonna remove the white space and we're gonna add this plus. Now, this base string earlier that we didn't really go over, this is actually the URL for the searched part. So we go here, you can see that this is actually the URL for the search part. So we can actually just put in any item after this part to find the item. So if I actually just type in magic candy here, magic plus candy, it should just come up with magic candy. Yep. So we're just going to add our magic candy to our base string, and that's how we get the item. And then it's going to print it because at the end of the script, that's how we're going to get it back to the Electron component. So we're going to make a new string output. Oh, and whitelist PKL. Oh yeah, I forgot to go over this top part. Whitelist PKL is just a packaged version of the whitelist.txt because we kind of don't want to create a new set of all 8,000 elements when every time we spawn the script. Because imagine if we look for one item and then another, and we're creating a set every time, that's a lot of overhead. So I just packaged it up, and I'm just gonna pass it to the Python process. So it just has it right from the beginning. So this part, oh, this is actually the tesseract part. This one right here, it just finds Python tesseract. So you actually need this. Python tesseract is a pre-trained machine learning library. So we need this installation for tesseract. But here's the waitlist. Gets the path, and then it loads it in. Now, going back, so we made an empty string to store the URL. So it says, hey, get the output from Python's output and get that string and append it to output. And then after the Python script closes, then we want to search for that item given the string. So we make a URL for the item, and that's just the thing we got. So it'd just be this whole thing with magic candy. We get this URL, we pass it into create item search. So going back, create item search was the control F part, like I mentioned. It says attempting to load this item. We make a window for it if it doesn't exist, and we pass in that we try to load in that URL, and we show it when it's ready. So that is how we get the control F part. And then this part is just creating an icon, making that menu exit item, and setting the name of the icon. And yeah, that's pretty much it. Thank you for watching, and if I made any mistakes in my explanation, please drop a comment and let me know. I will pin it, and I hope you enjoyed.